in this part we will discuss about change of state, factors for changing states. So let's see how can the matter be changed into different states. Can the matter change in states or not? Obviously yes. Matter can change in state from solid to liquid, liquid to gas, gas to liquid, and liquid to solids. So there is an easy diagram for you. Solids, liquids, gas. Solids can be changed into liquids on heating. Liquids can be changed into gas on heating. Gas can be changed into liquids on condensating or cooling. Liquids can be changed into solids or cooling. So here is an easy diagram for you to remember how can the change of state takes place in solid, liquid and gas. Is there some way to change gas directly to solids? Yes. When we have to change solids into gas and gases into solids, so we call this process as sublimation. Sublimation is the process by which solid can directly convert it into gas and gas can directly convert it into solid without changing into liquid state or without having the intermediate state between these two states, means that is liquid. Solids can be directly changed into gas and gas can be directly changed into solids on sublimation by applying sublimation. Sublimation is the special process by which solids can be changed into gases and gas can be directly changed into solids on without having the intermediate state, that is liquid. Without changing into liquid, directly solids to gas and gas to solids. So this is the easy diagram for you. I am requesting you to please draw it for your understanding easily. So now we move on the factors for changing in state. What are the factors, major factors that affect the change of state? First, pressure. Second, condensation. Third, temperature, and fourth, evaporation. So first we will see how pressure is important to change the state of matter. So here is also diagram. Solid, liquid, gas. So first we will see how pressure is important for changing state. So when peak pressure is decreased and temperature is increased, then solid can be changed into liquid. When pressure is decreased again and temperature is increased, liquid can be changed into gas. Now, when gas to liquid, we have to change the gas into liquid. We will increase the pressure and decrease the temperature. Pressure increase, temperature decrease. And to change liquid to solids, we apply the same pressure increase and temperature decrease. This is the diagram for changing solids to liquids, liquids to gas, gas to liquids and liquids to solids. Now condensation. Condensation only happens in liquids to gas and gas to liquids. Condensation, liquids and gas. changed into gas on applying heat. But gas can be changed into liquid on condensation. This what is the process that clouds obeys. When the gas clouds are on the top of the troposphere, they are in the gaseous state. On condensation means when these gas particles condensate, they form liquid and it rains. So we have completed condensation and pressure. Now we come to the temperature. Now temperature. Solids, liquids, gas. Solids can be changed into liquids by increasing temperature. Temperature increase. Liquids can be changed into gas on increasing temperature. Gas can be changed into liquids on decreasing temperature, and liquids can be changed into solids on decreasing temperature. So this what is the diagram for temperature. How can the temperature affect the process of changing state? Solids to liquids, liquids to gas, gas to liquid, liquid to solids. Okay. So temperature is one of the major factors of the change of state in the matter. So when these particles are applied to heat, when these particles are heat, the particles of this solid gain more energy. They get kinetic energy and begin to vibrate on their places. And when these particles vibrate, they move away from each other. That is why the solid changes into liquid. And same thing happens to liquid. When liquid is heated, the kinetic energy between the particles increases and the particles move away from each other and change into gas. When the temperature is decreased, means on condensation, gases to liquids, condensation. On condensation, gases are compressed together. The particles of gas are compressed together to change into liquid, and liquid particles on cooling compressed and so change into solids. So this one is the temperature. Now we move to evaporation. Now we come on evaporation. Because evaporation has four another factors, so I have explained it separately. So evaporation. Evaporation only change liquids to gas. Liquids to gas. Evaporation. Evaporation change liquid state to gaseous state. So what are these four major factors that affect evaporation? So let's see. Increase in surface area. Increase in surface area. What that means? When we take a glass and pour water on it and take another vessel and pour water in it, and when sunlight is directly over these two vessels, so which vessel has higher evaporation, rate of evaporation? Obviously this vessel, because the surface area of this vessel is greater and surface area of this glass is very little. So evaporation will increase. As the increase in surface area. So on increasing surface area, liquids can be changed into gas. On increasing surface area. Okay. Now, increase in temperature. We have discussed the temperature earlier, but evaporation, in this evaporation topic, one of the factors is temperature. So, when temperature increases, liquids can be changed into gas on increasing temperature. On increasing temperature, liquids can be changed into gas and can be easily evaporated very faster. So this is one of the major factors that affects the evaporation. Now, how can the increase in wind speed? Increase in wind speed. When the speed of wind is very high, when the speed of wind is higher, then the rate of evaporation between the particles is higher. As the wind speed increase, evaporation increase. Wind speed increase, then evaporation also increase. One of the best examples of this is drying clothes in the high speed of wind. We have already noticed when the clothes are dried on the wire, then the wind speed comes at very fast speed, and the clothes dry very easily, very faster. So, increasing wind speed is one of the major factors that affect evaporation. Now, decrease in humidity. So, decrease in humidity. So, let's see what is humidity. Humidity is the presence of water droplets in the air. Humidity is the presence of water droplets in air. So, when the water droplets are already present in the atmosphere, and evaporation also water change into water vapor. So, as there is much of the water vapor already present in the atmosphere, so rate of evaporation decreases. So, when humidity increase, then evaporation decrease. When humidity increase, evaporation decrease. These are inversely proportional because surface area, temperature and wind speed are directly proportional. What is the meaning of directly proportional and indirectly proportional? Directly proportional means when one thing increase, then another thing also increase. And inversely proportional is when one thing increase, then another thing decrease. And when one thing decrease, then another thing increase. So, humidity and evaporation are inversely proportional, means evaporation is inversely proportional. This is the sign of proportional. So, inversely proportional to humidity. Evaporation is inversely proportional to humidity. When evaporation increases, then humidity decreases. And when humidity increases, then evaporation decreases. Because there is already much of the particles present in the air. So when the evaporation occurs, then where do these water particles go? So the rate of evaporation slows down. It evaporates slowly. So decrease in humidity is one of the major factors that affect evaporation. Now let's move to the next topic. So now we come to latent heat. This is the one of the major part of this chapter. Latent heat. So latent heat are two types: fusion and vaporization. Latent heat of fusion and latent heat of vaporization. So fusion, when solids change into liquid, and required to change 1 kg of solids into liquids. 1 kg of solids into liquids on atmospheric pressure. Related heat of fusion is the heat energy required to change 1 kg of solids into liquids on atmospheric pressure. Same as latent heat of fusion, latent heat of vaporization is the heat energy required to change 1 kg of liquids to gas on atmospheric pressure. The latent heat of vaporization is the heat energy required to change 1 kg of liquids into gas on atmospheric pressure. So this is the latent heat of fusion and vaporization. As fusion takes in solids and liquids, when solids are changing into liquids, the fusion occurs. And when liquids are changed into gas, then vaporization occurs. So latent heat of fusion and latent heat of vaporization. The amount of heat energy required to change 1 kilogram of solids into liquids on atmospheric pressure is called latent heat of fusion. And the heat energy required to change 1 kg of liquids into gas on atmospheric pressure is called latent heat of vaporization. So here we are completed with the chapter. Now one more topic we have left, that what is non-matter. Non-matter is obviously the things which we cannot see, we cannot feel, they do not have any mass, do not occupy space and cannot be perceived by our senses. We can only feel them, only feel. These are mostly the feelings. Some of the examples of non-matters are love, hate, shadow, magnetism, heat, pressure, etc. So these are non-matters. They do not have any mass, do not occupy any space, and they do not can perceived by our senses. We cannot touch them, we cannot see them,